Exercise 3.2a, question 9. Consider the following summation when p is a positive constant, the sum from r equals p to p plus 30 of 1 divided by r minus 6 times r minus 4. For part A, it says, in the case when p equals 2, explain why the summation is not valid. And, okay, well, if you look at this thing, when p is equal to 2, it means we're going to start out when r equals 2, and then we're going to add the case when r equals 3, and we're going to add the case when r equals 4, and then this is a problem because this term is undefined when r is equal to 4. Undefined when r equals 4 or r equals 6. So p needs to be greater than 6 before the sum is valid. Otherwise we would need to write in here some way to exclude the case when r equals 4 and r equals 6. But the way it's written here, it doesn't tell us to do that. It tells us to start at p and keep going until we reach p plus 30. Now for part B, it says show that the sum from r equals 10 to n of this thing is equal to this thing over here. Okay, so let's get on that, and we're probably going to use partial fractions to do this. So we want 1 divided by r minus 6 times r minus 4 is equal to a divided by r minus 4 plus b divided by r minus 6 using partial fractions decomposition. And so we get that 1 is equal to a times r minus 6 plus b times r minus 4. And so we get that 1 is equal to negative 2a. And that's using r equals positive 4 rather. And then we also get that 1 is equal to 2b using r equals 6. Alright, so this thing is equal to negative a half divided by r minus 4 plus a half divided by r minus 6. And of course we can factor that half out, so it's a half. In fact, it's negative a half. Let's factor out negative a half times 1 divided by r minus 4 minus 1 divided by r minus 6. And so we are actually looking for the sum from r equals 10 to n of negative a half times this of 1 divided by r minus 4 minus 1 divided by r minus 6. And we've already done one like this where we use a little trick. So let's go ahead and use that trick again, because the difference between, well, the number in the middle of 4 and 6 is 5. And so we can actually just go ahead and insert a 5 in there. So minus 1 divided by r minus 5, and then plus 1 divided by r minus 5. And from here things become nice and easy. We know we can split this up into two summations. So minus a half of the sum from r equals 10 to n of 1 divided by r minus 4 minus 1 divided by r minus 5. And then minus a half times the sum from r equals 10 to n of 1 divided by r minus 5 minus 1 divided by r minus 6. And as I'm looking at it, I now see there was no reason to factor out the negative there, because actually r minus 5 plus 1 is r minus 4, so that was kind of a weird mistake there, but it's easily fixable. So then this is 1 divided by r minus 5, and then minus 1 divided by r minus 4. And then the same for the other one, plus a half times the sum from r equals 10 to n of 1 divided by r minus 6 minus 1 divided by r minus 5. And clearly for this one, well, the f of, so our f of n function, or our f of r function rather, is going to be 1 divided by r minus 5. And this time we're starting from r equals 10, not r equals 1. In the previous examples we started from r equals 1. But if you go from r equals 10, then r equals 11, r equals 12, the cancellations are going to be, they're going to work exactly the same way. So this one here is actually going to be f of 10 minus f of n plus 1, which is equal to 1 divided by 5. What am I doing? Looking at the wrong function. So putting n plus 1 into f, we get 1 divided by n plus 1 minus 5, so that'll be 1 divided by n minus 4. And I haven't multiplied by a half yet, so don't worry about that. And then for this one over here, same kind of situation, except this time we have f of r is equal to 1 divided by r minus 6. And so this is equal to f of 10 minus f of n plus 1 again, which is equal to 1 divided by 4 minus 1 divided by n minus 5. And so our purple summation is equal to 1 divided by 10 minus 1 divided by 2 times n minus 4. So I'll have a bracket. And then plus 1 divided by 8. And then minus 1 divided by 2 times n minus 5. Okay. So 1 over 10 plus 1 over 8 is 9 over 40. Okay, and then minus 1 over 2 times n minus 4, minus 1 over 2 times n minus 5, and we're supposed to simplify it to something. That thing there. Okay? So, we multiply everything together for the denominator. That's clearly going to be 4 times 40 times n minus 4 times n minus 5. And I think it was supposed to be 40 times something on the bottom. So we should end up with some multiple of 4 on top. So the first term on the top is going to be, well, 4 times 9 times n minus 4 times n minus 5. Plus, or I guess it's going to be minus actually. Minus, and then it's going to be 1 times 40 times 2 times n minus 5. So just 80 times n minus 5. And then the last one is going to be minus 80 times n minus 4. Okay, so continuing along, clearly we can divide everything by 4 on top and the bottom. So we get 9, and then let's expand out these brackets as well. So n squared minus 4n minus 5n, so minus 9n, and then plus 20. Wait, let me just check if they... oh, I think it's okay. So let's keep going like this. Alright, and then so 80 divided by 4 is 20. So minus 20n and then plus 100. And then minus 20n and then plus 80. And that whole thing is divided by 40 times n minus 4 times n minus 5. And then expanding everything out on top and combining like terms, we get 9n squared, and then it's minus 81n minus 20n minus 20n. So that would be minus 121n. Then we have 9 times 20 is 180, plus 80, so that would be 260 plus 100, so plus 360. And that's all divided by 40 times n minus 4 times n minus 5. And if you're not sure how to factorize the thing on top, a trick way is you can actually just set it equal to 0. So 9n squared minus 121n plus 360 equals 0. And then solving that equation, you can use your calculator or quadratic formula or whatever you want. So solving that equation, you get n equals 9 or 40 over 9. And so we know that this thing is equal to 9 times n minus 9 times n minus 40 over 9. And so that's equal to n minus 9 times 9n minus 40. Which is exactly what it was supposed to equal. So that takes care of that part of the question. Okay, for the last part of this question, it just says do it in the case where p equals 10. So we're starting at 10 and we're ending at 40. So it's basically just n equals 40. So let's take care of part C. So it's exactly this, but n equals 40. And so 9 times 40 squared minus 121 times 40 plus 360 divided by 40 times 40 minus 4 times 40 minus 5. And I get 62 divided by 350.